It's 1 o'clock. I will start with the introductions, and hopefully everyone who wants to join will be here by the time that I'm done talking about myself. So welcome to this second session of the RPA Forum. I'm co-chair Alexandria Satyani from University of Gothenburg in Sweden, and my other co-chair is Jose. Can you say a couple of words about yourself as well?
My name is Jose Gonzalez. I came from the University of Seville, Spain.
Yes, so welcome again. So we will have 5 very, very interesting presentations. You can see in your Zoom, you should see the Q&A function. You can ask your questions there, or you can also raise your hand and we will try to communicate your question to the speakers. But since we have very little time, let's get going. Our first presentation is by Yara Risk from IBM Research, and she will be talking to us about combination of the digital assistants and intelligent robotic process automation. So, the floor is yours, Yara.
Thank you. Hello, everyone. I'll directly get started about conversational digital assistants for intelligent process automation, which is a work I've been doing with my colleagues at IBM Research in the US. So robotic process automation, as most of us here know, has been one of the main drivers of the digital transformation, mainly because of its low-cost approach to automation, especially when we consider legacy software. So coming from an inside-in approach to automate manual tasks by automating the mouse click has produced some important advancements in incorporating automation to enterprise companies that tend to rely on legacy software. And so even though it has many advantages, there are a few disadvantages that include its lack of accessibility or interactive nature, especially for business users who may not be tech savvy. And also it doesn't allow a lot of collaboration between the different RPA solutions. So it's a bit difficult to compose RPA solutions into more complex systems. And so given the prevalence of natural language as a medium of communication in the enterprise world, we thought of chatbots as being one medium to incorporate with RPAs to kind of try to address some of these limitations. And what we present in this work is a multi-agent conversational system that basically under the hood hides a set of different RPA solutions and then has an orchestration layer that hides them to interface with the user through natural language using a single unified approach. And so before we delve into the details of what this framework looks like, we quickly highlight a few references from the literature. This is obviously not an exhaustive list, but we kind of include a few of the most relevant things. So mainly dividing the literature into business process automation related work that includes different RPA solutions for specific domains, but also how can machine learning and different AI solutions be incorporated to solve other RPA related problems like identifying eligible tasks for RPAs and things like that. And also for conversational agents, there is a long list of work that has been done there. But also there has been some work that tries to combine both RPA and chatbots, as we see here in the third reference. So let me quickly jump to a few definitions or terminology that we'll adopt throughout the course of this presentation. And so we basically define a skill to be some atomic function that expects inputs and outputs, or we call them needs and gots as well. And this skill has a certain contract that is relatively loose, but also can be categorized into one of 3 main types of skills that we define, which are understand, which basically means identifying a user's intent, act, which means performing an action like querying a database, for example, and then responding to the user in some human consumable way, such as natural language. And so one example of a skill is simply a natural language understanding skill that takes in a natural language input and returns the intent of the user. We also define agents, which are compositions of skills, but have to abide by a more strict contract. And in this situation, it expects a certain input and the current context of the world. And then we should be able to execute agents in two kinds of API calls, a preview request and an execute request. And we'll see why that's important in the next slide. But it should also return an updated context. Similarly, we can distinguish between 5 main categorizations of agents. This is also not an exhaustive list, but these are some of the most relevant ones to the use cases that we've been encountering. And obviously, one example of a visualization agent for our case would be, one example of an agent would be the visualization agent that has 2 skills, one of them an NLU that recognizes the intent of, for example, plotting data, and the other would be the skill that actually converts data frames into images of plots. And so the main component to this framework is the orchestrator that can handle these different agents and interact with the user in this unified natural language interface. And so what happens is that when a user submits a natural language input, our assistant can forward this input with, in addition to the user context, to all of the different agents that are under the hood, and then request a preview response from them. And they return a certain response in addition to a confidence that somehow quantifies how well they can understand and respond to the event that had just occurred. And then the orchestrator goes through a 3-step pipeline to create a score per agent based on the response that they have returned and the input and the context and the history of the conversation, things like that. So different things fall into just trying to compute a numerical value to represent these responses. Then a selector would pick which agent or maybe a couple of agents need to respond. And if more than one agent has been selected, a sequencer will order their execution before returning the response to the user. So once the sequencer has determined the order of execution, an execute request is sent to the appropriate agent. In this case, only agent 2 was selected, which then executes, creates the response that is then sent to the user in a natural language or human consumable way. Now, for each one of these different blocks, there are different approaches that we can adopt. For example, for the score, it can be as simple as simply using the agent confidence as the score. In that situation, we can use a simple selector that just picks the highest confidence. And then if we're only picking one, there would be no need for a sequencer. And just for the purposes of the demos that we will show in this work, the simplicity of the use cases allowed us to use some of the simpler options here, but we can obviously go into more complex systems where we incorporate machine learning and user feedback and things like that, which are some of our current projects. And so the 2 use cases that we will focus on in this presentation are a travel use case, where we say that in large enterprise companies, before employees can travel anywhere, they need to submit a travel request so that the company can approve the request and pay for the expenses. And that tends to be a 3-step process where an employee submits the request, the manager reviews the request, and then the director also reviews the request. And you would need 2 approvals to consider the application passed. And then we also consider loan applications process in business, in banking institutions, where a customer submits a loan application and then a loan officer needs to make a decision about whether it should be approved or not. And so we create a single business process assistant that can basically handle 4 different personas that we had just seen: employee, manager, loan officer, and bank customer. And then we have agents that can handle different tasks within these 2 business processes that fit within these 5 categorizations that we had already mentioned. And we can also group them into those agents that are domain agnostic. So they don't really care if we're talking about travel or loan or whatever, they kind of apply to different things. So, and the visualization is one example that we've already seen. Content analyzer that takes in a PDF and then extracts key value pairs from that PDF is another example. We have domain-specific agents that...
2 minutes left, sorry. Yeah.
Thank you. We have domain-specific agents that are specific to, let's say, the travel, or they do something very specific and they cannot extend to other domains. And then we have some agents that are instantiated for a specific domain. So for example, we have a natural language to query agent that can, if you instantiate it on a specific database that has data there, it will create an ontology and then can query, for example, travel as opposed to querying loans. But that overhead would be less than, let's say, creating domain-specific agents. And so all of these agents can be, we can interact with them in a natural language way. And they can also collaborate based on this infrastructure of the orchestrator that we've provided. So a bank loan officer can come and ask questions and have the business rules engine figure out whether a loan should be approved or not by providing the right input. But we can also have the content analyzer agent take in a PDF of a loan application, process that, and then the business rules engine would take the context from this first agent and then perform its operations without needing to interact with the user. So this is where we see this collaboration of RPAs happening, in addition to, on the left-hand side, the interaction between the user and the RPA solution in natural language. So here are a few more examples of just conversational ways of interacting with different agents. We see here which agents are being called, and we can also see some of the responses may not necessarily always be natural language, but can be a figure or a CSV file if that is what the user asked for. So to conclude, we basically propose the framework that allows interactive business process automation through natural language, but also a collaboration among RPA solutions through this multi-agent orchestration infrastructure. And this basically allows business users who are not very tech savvy to interact, monitor, customize their business process solutions through natural language. And for future work, we will be focusing on some more sophisticated orchestration models that we briefly touched on before, like machine learning and things like that, to handle more complex systems, but also to add some additional automation agents that can handle certain aspects of business process tasks that we haven't dealt with yet. And so I'll end here, and I can take any questions that you may have. Thank you.
Thank you very much. So please, if you have any questions, either raise your hand or post your questions in the Q&A. I can perhaps start with a question while others are gathering their thoughts. So you mentioned that you have sort of future plans for this framework. So what do you think, what would be the focus of the next steps within this orchestrator?
Yes, so some of the main things that we're currently working on are really this orchestration side of things. So we had mainly touched on top K, the identity function as in confidence. One of the main problems that we can immediately think about here is if we have different people, different developers creating these different RPA agents, maybe confidence is not normalized across them. So one of them can come back with, they always come back with high confidence versus others, they tend to come back with low confidence. Maybe the range of the values is a bit different. In this case, they were all between 0 and 1. Sometimes that's not the case. So sometimes you would need to have some more sophisticated scoring mechanisms to make sure that we're really comparing apples to apples, right? Another thing would be that, let's say a certain user prefers one type of RPA over another type of RPA. So even though all of those RPAs exist in the system, the orchestrator based on user feedback, which can be like thumbs up, thumbs down, would basically take into account the user's feedback and preference on whether they prefer, let's say, always calling the content analyzer agent as opposed to maybe calling some other solution. Like they prefer to be asked questions as opposed to having a PDF be uploaded. And so in that case, the selector would learn that there's a preference to pick one agent over the other, and that would also be basically used. So instead of top K, we would use something like reinforcement learning to incorporate user feedback. So that's very briefly two of the most immediate things that we will be working on.
Okay, thank you. Are there any other questions or any? Doesn't seem like it.
No questions
Any-
in the chat.
Any questions from the panel? No?
No.
Okay. Just then, like one very short question again from me. So what is, in this development process, did you identify any sort of good practices for the good orchestrator design? Are there any essential parts there that you want to highlight? Maybe one or two.
Yeah, so like, for example, currently in the way that we had done I mean, I don't know if we would call them good practices, but maybe things that would make the problem simpler, basically. And so, for example, when we had these different RPAs, if there wasn't a common vocabulary, so the content analyzer needs to extract certain variables that would feed into the business rules engine that would figure out, based on the inputs, what decision to make. So as a first step, we had implemented something where it was everyone speaks the same language. So at the beginning, we would have to register these different RPAs and say, these are the variables that we generally use as naming convention. But what we had then moved forward with was a way to basically automatically match variables. So if someone uses first name versus using, or last name, and then the other uses surname, for example, then we created a function in the middle that maps between those. And another thing that we also kind of would try to incorporate in our system is a lot of fallbacks. So sometimes an RPA agent may fail, things like that. We need to make sure we have a fallback to, let's say, a human where the user will provide the input and things like that. So basically having a lot of safeguards as well would also be considered good practice, especially in highly regulated industries where any mistake or something like that can be very costly. So that can be considered a good practice as well, is to have a lot of safeguards.
Okay. Thank you very much for the interesting presentation. I think it's a really exciting work. But let's then move to the next presentation. And here we have Johannes Viehhauser from Technical University Munich asking the question, is robotic process automation intelligent?
Thank you very much. A warm welcome also from my side, Johannes Viehhauser from Technical University of Munich. I want to introduce you to our research findings on the question RPA and AI, and is RPA becoming intelligent? For this presentation today, I want to give you a brief overview on the initial situation and a research question, run you through the methodology, and in particular, of course, introduce the key findings of our research on RPA and AI. Well, as many of you may know, in recent years, on the one hand in corporate world, but also in research, there have been indications that RPA is becoming smart and intelligent. A lot of authors indicated that RPA, for example, includes optical character recognition to detect unstructured text, or, for example, machine learning capabilities in order to be able to learn in cooperation with human users. But to date, research mainly focuses on simple RPA in terms of RPA that executes well-structured and routine tasks based on explicitly defined rules, and little is known about RPA with intelligent capabilities, or RPA with platforms that include intelligent capabilities. And therefore, we ask the question, how does AI impact the capabilities of RPA on the one hand and its applicability, and on the other hand, what does it mean for the suitability of task characteristics and processes where RPA can be applied? Most important for that is, of course, to define intelligence in order to be able to judge whether RPA is intelligent. Therefore, we applied a definition by Kaplan and Herrlein, who defined AI as the ability of a system to correctly interpret external data, to learn from such data, and to use those learnings to achieve specific goals and tasks through flexible adaptation. And actually, they've identified three types of intelligence: cognitive, emotional, and social intelligence. Social intelligence, for example, in terms of empathy; emotional intelligence in terms of self-awareness, which are, in our view, not well suited for RPA. Therefore, we left them out in the research. And based on cognitive intelligence, we then derived a framework and asked the question whether RPA is able to fulfill those criteria shown in the framework. This is, on the one hand, is RPA able to capture information in terms of text and character recognition, image recognition, and voice or sound recognition? And on the other hand, is RPA able to process information in terms of, for example, natural language processing, meaning understanding sentiments of text, for example, machine learning, and automated reasoning. And based on this framework, we've conducted 9 case studies with RPA software providers and cases that they have actually implemented based on their RPA engines. And to have a bottom-up validation, we conducted interviews with 6 RPA integrators who apply the software of the RPA software providers in order to get a bottom-up validation whether their results are valid or whether they maybe over-exaggerate the findings and their capabilities of their tools. What we found out in this case study is that actually RPA has only very limited intelligent capabilities, and as a rule-based engine, it does not need intelligence because otherwise the intelligence would contradict the definition of RPA to provide rule-based and reliable results. Nevertheless, when we look into the detail, we found out that in terms of capturing information, all 9 examined robots are able to collect collect data from text, meaning, for example, reading texts and emails, and also be able to provide keyword searching for certain keywords based on predefined rules. In terms of processing images and scans, we detected that 4 of the examined RPA solutions contain some kind of basic OCR, optical character recognition. Therewith, they were able to read scanned documents which have computer written texts, and only one of the solution actually provides advanced OCR in terms of really being able to work with unstructured texts. This was somehow surprising because at least in a couple of articles, it was stated that RPA should include optical character recognition capabilities. What also become prevalent is that 7 out of 9 solutions contain computer vision, which is also kind of, or incorporates kind of OCR capabilities. And this is of course something that really suits to RPA because it enables RPA to work on remote screens, to detect buttons or text on the screens, and therewith is able to work in a no-code environment. In terms of processing voice or sound as more complex information, RPA is not able at all to process those information. On the information processing side, none of the RPA solutions provide any kind of natural language processing or automated reasoning capabilities, which actually would be core features to say that a tool is intelligent per our definition. But what we detected is that machine learning is more and more used for RPA, and it's very well suited for RPA in case that it increases the applicability or efficiency of RPA without affecting the reliability of results, for example. What we saw is that the tools that have OCR capabilities also provide machine learning based document and text classification capabilities so that they are able to, in cooperation with the human users, detect and classify texts and documents. Of course, all the tools that provided computer vision capabilities also have some kind of machine learning, which is a part of computer vision. What was interesting is that one solution, one RPA robot was able to provide a recommendation engine, meaning that the robot could learn based on the behavior of the human user. And then if a certain failure occurs various times, could implement the change into the workflow without requirement for coding. And 2 of the RPA solutions provided some kind of machine learning based scheduling assistance, which enabled the RPA solutions to schedule and orchestrate various robots, or that one robot was able to perform multiple tasks based on machine learning based scheduling. And this is something which perfectly suits to RPA and therefore should be incorporated into RPA tools as machine learning capabilities. What we also detected is that all of the nine RPA providers and RPA software solutions have been embedded in RPA platforms, and all of them pursued a strategy to incorporate cognitive intelligence as of per our definition as external components, which actually makes totally sense because RPA as a standalone rule-based execution engine would be untouched, and everything and all intelligent components that you need to automate a certain process will then be added modularly via drag and drop and the platform approaches. This is something that is referred to as intelligent automation or intelligent process automation, also in literature. What we could see in the data is that mainly optical character recognition was available at all 9 platforms as pre-installed capability, and therefore most RPA providers used external technologies such as ABI or COFAX, for example. And 4 out of the 9 RPA platforms, they also had pre-packaged natural language processing, mainly in the form of sentiment analysis, for example, to understand context of emails, and they would be able to work with unstructured text coming from emails, for example. However, if you look at those RPA platforms in the view of our framework and definition for cognitive intelligence, then it becomes obvious that also those RPA platforms still lack intelligence, mainly in terms, of course, of automated reasoning and the performance and work with very complex and unstructured input data, for example, voice and sound. But this is something that is not, at least at the moment, not part of many or most RPA projects, because you start with very simple and rule-based processes, and pretty sure within the next years, if the processes will become more complex, then also those features could more and more be added to RPA, but then, as already said, modularly with the RPA platform approach.
You have around a minute and a half. Yeah.
Perfect. Beside the question how whether RPA is intelligent, we also looked at the question based on the case studies conducted, how does the increasing intelligence of RPA or RPA platforms impact the applicability of RPA? The main finding, of course, is that besides RPAs becoming more intelligent, processes that are rule-based, of high volume and repetitive are still the best process candidates for RPA, even though it might become a bit more intelligent. However, the cognitive capabilities included into the platforms and RPA engines of course broaden the applicability of RPA, however, at the cost of complexity and implementation efforts for those projects. And we identified actually 3 focus areas where intelligence has impact. On the one hand, the requirement for structured data input becomes less important, obviously because of the usage of OCR, which enables RPA to work with, for example, scanned documents. And on the other hand, the need for a high degree of standardization and clearly defined rules and the maturity of processes also becomes a little less important because, for example, based on machine learning, especially supervised machine learning in cooperation with human users, RPA is able to also deal with exceptions and incorporate exceptions that have been approved by human users into the processes. Nevertheless, as already mentioned, it's of course still the best to have a rule-based, standardized, mature, and high-volume process. So coming to an end, we found that even so, and despite being argued by software providers and also literature, RPA is not really becoming more intelligent. RPA as itself should stay as a rule-based execution engine with only intelligence that make it more applicable, but it still needs to be reliable in the outputs. And all intelligence that is needed is actually added via the platform approaches, which is also absolutely sensible because therewith it enables a flexible adoption of RPA in combination with intelligence. Thank you very much for your attention, and happy to answer questions and discuss with you.
Thank you, Johannes. So if we have any questions, now would be a good time to ask me. Okay, Andres has a question. So, okay, Andre.
Hey, hi, guy. Can you hear me?
Yes.
Yes.
Okay, thank you for Johannes for your presentation. I think we still think it's not intelligent enough to to what we consider intelligence so far. So my question is about this: what we consider intelligence. In a previous project, we were thinking that RPA will be able in, I don't know to say, close future, to be able to deal with adaptation of processes. So my question is about your opinion of how far do you think we are in the context of intelligent or cognitive or whatever intelligence we are talking about, but how far we are from a robot who is able to adapt the workflow to changes in the user interface, for example. So we have a form which has a submit button, but tomorrow this form change a bit, but the context is the same in data, but you have this different look and feel. Today, the robot gets stuck at this point. So in your opinion, in your studies you have conducted, have you seen some kind of functionality that is targeting these things?
Thank you for the question. Very interesting. And yes, we did come across this actually a couple of times during the interviews with software providers. Something that actually combines OCR and machine learning technologies. And I think at least 3 or 4 of the providers are currently working and are about to release exactly those technologies to be able to even more work with changes in the workflows or with changes in the user interface without the need for human intervention. So this is something that came across to us, and also for me, I think it's the next step for RPA. However, as it is not available today, we couldn't include this feature into the framework.
Thank you.
Okay, thank you, Johannes, for an interesting presentation. But we'll be now moving on to our third presentation by Antonio Martinez Rojas from University of Sevilla, and we'll be continuing with the theme of the intelligent RPA. So this is about cognitive RPA components. Antonio Martinez, floor is yours.
Hello, can you hear me?
Yes.
Okay. I will. Okay. Good morning. I am Antonio Martinez from the Web Engineering and Early Testing Research Group, and together with the help of my colleagues Irene Barba and Jose Gonzalez, we have made possible the work towards a taxonomy of cognitive RPA components, which I will present next. Here we see the index of the presentation, which is divided into 4 points. The context, which shows where it comes from and what are the motivations of this publication. Then the proposal of a method for the systematic construction of a taxonomy of cognitive RPA components from hereafter ERPA, followed by the taxonomy resulting from an iteration of this method, finishing with the conclusion of this work. Let's start with the context. Nowadays, robotic process automation is a discipline that is increasingly growing hand in hand with artificial intelligence, enabling the so-called cognitive automation, which translates into cognitive RPA components or ERPA components that are offered by the main platforms of the RPA. What is the motivation for this publication? Well, when an RPA developer wants to automate a process and he identifies its cognitive tasks, then when looking for a component on the market that solves this task, he will find that each platform classifies similar components in a different way. So the main motivation for this ERPA components taxonomy is that we find in the market that none of the main RPA platform, neither UiPath, Blue Prism, nor Automation Anywhere, follow a specific classification or classification standard. Here we see a concrete example that illustrates how the component intelligent form structure, or the other two, extracts elements from unstructured data and give an output of such data in a structured way, doing exactly the same. Therefore, all three components solve the same task, but are classified differently. And that's the main problem we want to solve. The first solution we would think is to define a new taxonomy to be the new standard. However, that solution is, as Friends says, is not going to be the one we take. We are going to propose a method to unify the knowledge we have and build an incremental taxonomy. Why? Because in this way, we will reduce ambiguity when similarities appear. For example, in the previous case of intelligent OCR and document processing, which are equivalent terms. We will save traceability by following this method. For example, when we forget that categories from one of the knowledge source consider a specific context, we could quickly locate all terms that come from that knowledge source and solve the problem. And the most important part of this proposal is what this man tells us, that if I think that the term image processing better represent the concept than the taxonomic category computer vision, how can I change them? Well, in our method, we introduce the necessary techniques to extend and update the tree of taxonomic categories, obtaining the incremental taxonomy of RPA components, which we will define next. How is this taxonomy constructed? First, we define the first level composed by classification, processing, and governance. We propose that these three categories cover the whole spectrum of RPA powered by AI, according to its scope, based on Sharper AI knowledge source that give a classification for the AI by scope and adapting it to the RPA through the proper knowledge and the industry's knowledge provided by Sermiform company. In this way, how we define a category within this taxonomy. Having this taxonomy, we find that it is formed by taxonomic categories or task-cate, which we see here abbreviated. Each of these categories have the terms of equivalent categories associated with it. A taxonomic category will be defined by the same properties as any category term, except that it will be understood as the representative of those associated with it. Thus, both categories, category term and task-cate, will have a series of properties associated with them. The terms which correspond to the category title, for example, classification, the category characteristics that are a description of why a component belongs to the category, the input format supported, for example, we see here the case of image, and the most important part that corresponds to the knowledge source from which the category comes, for example, WIPE. What is the most important part of our taxonomy? Its incremental character and how this taxonomy increase. First, we have an idea of a new category to add to the taxonomy. Then we register the knowledge source from which it comes. Then we register the rest of the properties of the category term, that is, the term itself, the format supported, and the characteristics. Once the characteristics is defined, we have three options. Given the taxonomy, if we consider that no equivalent terms, that no equivalent category exists, we include the new category as the daughter of the most appropriate taxonomy category to contain it. The second option will be to replace a taxonomic category with the new one. In this case, the taxonomic category go to the list of equivalent terms and the new category become the taxonomic category. And the last option, when the taxonomic category better represents the concept than the category we want to add. Therefore, we simply add to the list of equivalent terms associated with it the taxonomic category that we believe best represents its concept. We will also call this RPA Unified Knowledge. As you can see here in this tree, each taxonomic category has associated its equivalent category term and the knowledge source from which these terms come. Here, in this specific example for the computer vision taxonomic category, it is surrounded by each of the category terms from YPath, Blue Prism, and Automation Anywhere, bearing in mind that there can be several equivalent terms for the same category coming from the same knowledge source, as is the case here with YPath. As an application for this method, we obtain a first version of the taxonomy that can be increased. This is the taxonomy that have been obtained as a result of the study of the main RPA platforms and the knowledge from Sermiform and our research group. We can see that these three have, for each node, as defined above, its associated equivalent terms. For example, in the specific of elements, it's seen how element datation is considered equivalent to intelligent OCR and document understanding from UiPath, document processing from Blue Prism, and IQBot from Automation Anywhere. Heterogeneous categories to classify similar components. It should be noted that the latter corresponds to a component, since Automation Anywhere does not offer categories, but packages with the components directly. Likewise, the rest of properties associated with the category, such as input format supported, are stored for each node too. How can you classify a component with this taxonomy? Here we see this developer who is a bit desperate, and he noted that through our taxonomy could easily find the category in which each component is located. To do this, he explored the categories for of the taxonomy, starting with the first level, and see according to its characteristics which of them are most suited to the need he wants to cover.
2-minute warning. 2 minutes. Yeah.
Okay. He will be repeated until reaching the deepest level possible, and to find which category is going to group in the components that solve his need, which is in this case is translation. The result is that in order to automate a process, the tasks of an RPA process that need artificial intelligence are identified, and unlike the case presented at the beginning, in which RPA developer found different categories for similar components, now through our taxonomy, the developer will be able to find directly the category where are located the components he is looking for. So RPA taxonomy helps developer to easily find the components they are looking for. In addition, it helps to locate the components he wants in any of the platforms studied, whether UiPath, Blue Prism, or Automation Anywhere. He could consult our knowledge source, see which are the equivalent categories, and go directly to the category of the platform he is using to develop the robot, without wasting time or falling into errors due to this task, which today is quite complex. As conclusions, we obtain that for the problem that we have commented, in which the developer asks himself where are classified the components that solve its necessity, we find a solution, a structure of a taxonomy that has as objective a method to increase it collaboratively, where we have made a proposal using information available in the main RPA platform, industry knowledge of ServInform, and the scientific knowledge of our research group. And as a result, we obtain a tree with 16 taxonomic categories. But the most important thing is about this approach is its incremental character. And at the last point of this presentation, we have the future work. First, we are considering to include the output format of the components as an additional way to distinguish the categories. For example, in the case of computer vision, we have that it is possible, in addition to the input format, to distinguish it by the output format, which could be, for example, text or JSON, among others. But it has not been included within this work as it has exceeded its time and scope. One of the great challenges we face is to structure the characteristics of the categories, since to determine the belonging of the components to the taxonomic categories, right now, it is only identified by plain text, but so it would be necessary to include logical rules to identify the belonging formally. Something that would allow, linking to the last point, to extend our taxonomy is to automate the classification of the component using machine learning techniques, taking advantage of the commented logical rules. Although, in addition to this, we can also extend the taxonomy by including a moderator to determine which of the proposals made to the taxonomy should be accepted or rejected, and also to include the concept of confidence. So there will be knowledge source for more relevant than others. For example, giving more weights to the categories coming from the main platforms, such as UiPath, since they have more presence in the market. And that's all. Thank you for your attention.
Thank you very much. So we have time for a question, perhaps, if there are any. Yeah, not at the moment. Yeah, so maybe I can ask one question. So perhaps this is the basic question. I'm not an expert on that part of the RPA, but who is the target audience for your taxonomy and how is it going to be used in practice? So.
We define two actors, like providers and developers. Providers meaning the people who offer the components, like Whitepath, Blue Prism, or other competitors, and developer like not only the programmers, no? But all the people that are involved in designing or programming the robots.
Okay. And do you have any plan on sort of getting those players on board, especially the providers?
Sorry?
Do you have any plans sort of how to get providers on board using that taxonomy?
Well, it's difficult task.
Okay. Yeah. Okay, there doesn't seem to be any questions. So then I think, thank you very much, Antonio Martinez. So then I will give Jose, my co-chair, the role of.
Okay, thank you, Alexander. So next move to the next presentation. The next presenter is Rafael Cabello. He comes from the Serviform company from Seville, and he's going to present the paper entitled Beyond the Hype, an RPA horizon for robotic human interaction. So, Rafael, when you want.
Okay, thank you very much. I'm going to share. Okay. Sorry. Okay. Well, as you know, RPA is going fast in the market and has been adopted in a lot of organizations. As ourselves, I am Rafael Cabello, and I'm the Digital Transformation Director of our Serviform. And what means RPA for us? It means efficiency and flexibility. But we are facing since 2-3 years ago large RPA deployments. We are talking about 50, 60, or almost 100 robots. What does means? We need agility, reutilization of components, machine learning to have less human in the workforce. Very important, we have to assume that not everything must or can be done by robots. So what? You must put human in the real loop of the process. So we are facing that the best scenario is to have a hybrid scenario, robot and human, real hybrid scenario, taking the best of both works. Robots, systematic, high volume, it's a technology that has have improved with a lot of technology. We were talking previously about UPath, Blue Prism, automation anywhere, but humans can do a good work for non-common and cognitive actions. This is the real. But how we face this hybrid scenario? First, as any RPA project, you have to think from the start, from end to end, with the real actions. And the devil is in the details in RPA projects. This is not a beautiful technological project. There are a lot of teeny details. So we have developed framework to face this. First step is identification. Identification of which activities can be done, must be done, or should be done by humans, which ones should have carried out by robots. That segmentation has to be very clear, and you have to prevent the human takes cases from the robot. In RPA projects, we use the Dr. House methodology. This is funny, but it's very practical. Everybody lies. You have to just put confidence and validation about what everybody says about the process. And second, step number 2, you have to identify the checkpoint. What checkpoint means for us? Checkpoint is when the action that has been done by the robot switch, and from that point, the process is carried out by the humans. So there is a switching of the ownership of the process, and the process goes. The human must have all the data and all the information to perform the task, and you must avoid confusion of what can be done for a robot, what can be done by a human. Step number 3, this is something psychological, but you have to get the feeling, the human feeling of the man control the process, even if the real thing is that you put a McDonald's vision of the process, because some systematic actions are carried out by the robots, another cognitive and or maybe difficult actions are done by the humans, and the rest of the actions are done by the robots. But in any case, the human must feel that they drive the process, even there is not real. As I said, you have to give the data to the human to prevent to go for another path of the process or trying to check information. And it's very important that you identify what means okay for the process or action and what means a fail. This is very important, yes, as we will say later, to check the result of the process. To get it real, you have to deliver. We call it control room. Control room is that tool that delivers the checkpoint in the process, performs the collaboration between the humans and the robots, provide information for the human to perform the cognitive actions or the manual tasks. You have the full vision of the cues, the real cues of the actions that are performed by the robots or the human in real time. And in case of there is any need, you can have the possibility to switch the workload from the robots to the lot if any break in the process. And very important, this control room must generate the central repository of all the data that is the result of the process, all the actions, all the details of the evidence, because this is the tool that will provide post-mortem analysis. RPA projects are good when they are okay, but when you have fails, when you have chaos, you have to check what is the reason, because human can fail, but robots cannot fail. So you have to have at one click distance the knowledge of what was the reason for the fail. You have the repository to generate the KPIs, the indicators of the process, and we are using this for introduce process mining in the projects. Well, this is good, but the real thing is that we have delivered this in a real project for an electrical company to manage claims. We are talking about 6,000 claims a month. It takes the process more than 20 minutes. Well, it took 20 minutes to perform all the actions related to manage the claim. When a client say, hey, I don't want to pay this 200 bill. Well, and the robots, we have a farm or more than 20 robots extracting data from a CRM, a Salesforce, and a commercial system, extracting the data, and the control root provide the data for the human to make the cognitive action to say, hey, this claim is okay, or we should get the money back to the client, and another farm of robots execute the decision. And the control room provides this to switching the point to put all the information for the human to take action. And also this is the Trojan horse to introduce machine learning in the process, because the data that are extracted by the RPA, we have the decision that is performed by the humans. We are talking or more than there was more than 10 people in the process, no much less. We have the data, we have the decision that has made by the humans. So let's put
2 minutes left. So
okay, thank you. I'll go fast. So we have get more than 70, yes, I say 70% efficiency in the process, providing this collaboration between human and robots. And conclusions for this type of real projects. Usability. Usability is a key thing. You have to get the feeling that the humans have all the information to carry out the process. There is no need to check anything, and they must go fast in the process, because there are a lot of friction to put this in the real project. There must be easy, clear, and complete information when there is needed to be used by the person that requires. You have to provide data extraction and maximum capacity. The robots, the data that are extracted by the robots cannot be the bottleneck of the process. Failures are real. You must face this fact, but you have to put the tool to get those failures, to know the reasons, because there are the next step to increment efficiency, eliminating those failures and providing more efficiency. Okay, that's all. Thank you very much, and I'll be glad to respond to any question.
Okay, thank you very much, Rafael. Is any questions? The Q&A? Not?
Nothing so far.
Okay, so I will start with a question related to your framework. How did you do in the identification and design of the process? I mean, do you do it in a systematic way, or do you do it always by the same way, or it depends on the cases of study, or I don't know?
We approach a systematic focus on how to identify every action, but we rely on what the people that carry out the process says, what we check that they do, and the information that are stored in the process. We are using this tool. In some cases, we use some tools like UiPath task mining, but this is something that we are introducing now in the projects. We have some tools to extract what the people in the process are doing through key log, screen capture, and monitoring with video. And we use those tools to analyze the project, to identify those real actions. But this is when the process is large, there are a lot of FTH involved, and when the complexity requires.
Okay, thank you very much. I have just one more question. It's regarding to the case study that you have performed with the electricity company.
Yeah.
You have been telling us about you have executed too many cases, and they have like a lot of inquiries a day and things like that. And I don't know if you have think about how to, or you are doing testing about your robots. So it means I can imagine that this electricity company do not provide you a testing environment just to test what the robots or what the robots should do and what we expect that the robots do. So how do you manage these kind of things?
Well, this is very important. This is a very good question. In RPA projects in general, there are not development environment, or even if there are development environment, you don't have the real cases because the claims have to be solved in less than 24 hours. So what how we solve this? Design of the process. Step one that I talked before, build the robots in small pieces that are very well validated with real thing, and proving that at the end of the process, the result of the process is good. You have to be very, very careful, but this is just work. There is not magical tool. Yes, design, validation, and you have to have the panic button to stop the process when there is something that goes out of the control. For that reason, the control room is very important. When you see that the failure rate is getting higher, higher, and higher, something has changed in the process or in the system. So you have to have the possibility to stop the process, to stop that path of the process, but keep the rest of the paths running.
Okay, so thank you very much for your presentation, and I think then we can move for the last presentation. Yeah, the last but not the less presentation is will be presented by Yara, isn't it? Right. Again, so she doesn't need any more presentation. She's going to present the paper entitled From Robotic Process Automation to Intelligent Process Automation. So, yeah, Yara, when you want, you can start.
Thank you. Hello again. So yeah, I'll be also presenting this work that is by the same team at IBM Research. So to quickly motivate this work, we all have been hearing about this digital transformation, Industry 4.0, but really some of the main drivers that kind of allowed this to come to bear, this digital transformation, was the prevalence of business process management in industry. So it's estimated to exceed $16 billion in about 3 years. So that's a huge market. Artificial intelligence has also been shown to have a significant impact on the business value, and numbers are being approximated at almost $3 trillion of impact. So businesses that aren't making use of artificial intelligence would be losing a lot of value. And then obviously with the ubiquity of computing resources, from hardware, the cloud, all of these things becoming way cheaper, it's making it much easier and more accessible for a lot of companies to adopt software automation solutions. And so we had already seen that robotic process automation has been one of the main drivers for this transformation because of their low-cost approach. But as Johannes has already mentioned before, that maybe they are not as intelligent as some applications may require them to be. So if we're going to say, let's keep them as is, we may need to move into something that is being called intelligent process automation, where we have a tighter coupling between AI and RPAs to achieve more complex tasks in the literature or in industry. And then beyond just IPAs, as Raphael had pointed out, not everything can be automated. So we still need this human in the loop. And to achieve end-to-end automation with the human in the loop, a portion of the literature is looking at what is being called, at least by Gartner, hyper-automation. So those are kind of the different tiers, and we'll mainly be focusing on in this talk how to go from RPAs to IPAs. And so a quick background, although I think almost everyone here is pretty familiar with these terms, but business processes are, for now, let's just call them collection of connected tasks. One example of that would be this mortgage loan application, where different tasks need to be executed in a certain sequence to achieve the end goal of approving or rejecting a certain loan. And in this case, we're using the BPMN graphical notation to represent this. There are different softwares that can be used to manage business processes, manage the tasks, the people that are performing such tasks, or like maybe the software assets or automation solutions, ensuring, monitoring the process, make sure KPIs are being properly followed and being met and things like that. And so as we move into business process automation, where we try to inject automation into these business processes, whether through RPAs or through other back-end automation solutions, we need to make sure that we're monitoring and improving our efficiency. And a few ways to monitor and kind of analyze the performance of processes in the business process world has been kind of these different types of key performance indicators like time, cost, quality, flexibility, and all of those are very important. Even though they have been used in the past, it is even more crucial for them to be incorporated as we add more automation into these business processes to make sure that we're getting a good return on investment. And so this is where in the digital transformation of these business processes, it's not only important to provide RPA solutions or just automation solutions more generally, but it is also important to identify where the high value automation opportunities lie and how we are evaluating and improving these solutions throughout their lifetime. So within the scope of RPAs, the main focus is on automating repetitive tasks with this outside-in approach, as we had already mentioned, because it's less costly in the realm of legacy software. It is, other than proposing these solutions that can, so the RPAs would basically automate a specific task, there are a few steps that go into creating these RPAs. First, we need to make sure we have a good source of the data to be able to have some training data to learn the tasks that the RPAs need to learn. We need to identify automation opportunities, and then we need to design, train, and test these RPA bots before we can deploy them into the real world. Once they're deployed, we really need to make sure that we continue to monitor performance so that they are behaving as expected. Now, focusing on how we can teach these RPAs, there are three main approaches that kind of fall into two bigger categories of human dependent versus human independent. Within human dependent, we can divide things into two subsets. By example, where humans are kind of demonstrating in front of the RPAs how to perform a task, or the RPAs are mining the user logs or behavior logs to figure out what to do, versus trying to understand how to perform a task from natural language instructions. And then the third category, which falls into the human independent bigger realm, is learning from the environment. And we'll discuss that in a second. But so let's quickly go through, again, this is not an exhaustive list of all of the references out there, but just a quick snapshot of what exists in the literature. So by example, we can basically create rules from forms. If we are mining the user logs, we can use inductive program synthesis to learn the rules behind input-output examples. So how to go from the input to the output by just providing examples, we can use program synthesis to derive these rules. And so this approach is very popular, but it does not generalize as well because it is more dependent on the user logs or the environment in which the rules were learned. From natural language, this is basically, you have a lot of natural language documents, you want to understand them, so you can use many approaches from the natural language processing field in artificial intelligence. That includes deep learning or supervised shallow learning, like support vector machines in this first example. And so while this approach does not require an embodied process, so you don't have to have a process implemented in BPM or some other management tool, it is more difficult to learn rules because you are more constrained to the how advanced the natural language processing technology is. And in this last one, we're basically saying that RPAs will be released into an environment that provides feedback. They start exploring, performing tasks. Maybe they fail, they'll get rewards, they'll get punishment based on how they perform, and they end up learning how to perform a specific task. And basically this relies on reinforcement learning from the AI literature. And while this would basically produce the most generalizable RPAs, they are the least mature. And from our search, we could not find any specific references that handle this exact task.
2 minutes left.
So moving into the IPA realm, there are a few problems that need to be solved that include not just automating simple repetitive tasks, but also automating more complex tasks. We need to reduce the cost of building and maintaining these solutions. We also need to make sure they are trusted so that these risk-averse enterprises will be more likely to adopt them. And we also need to make sure that they can collaborate and coordinate, as we had also seen earlier today. And so some of the research opportunities that exist here include process mining or different things in business process automation, such as process mining, automating certain routines, addressing the fact that we're in highly regulated domains. Another thing is how can we compose and synthesize these RPAs into more complex IPAs, making sure we're managing risks, making sure we're providing a natural language interface for business users to cooperate or to talk to their automation solutions. We need to make sure we're providing explainable solutions to, again, address the idea of a trust, and making sure that machine learning-based solutions do not discriminate, are not failing when things are, when we're in mission critical applications and things like that. And also a very important point is to look at business process automation as a new modality in machine learning, where we have, or at the very least, a multimodal problem, basically, where we have different modalities and we need to exploit different machine learning solutions that combine all of these to maximize how much we're learning from the problem. So a few months ago, when travel was still a thing, there was an IPA intelligent process automation workshop that happened at AAAI. I will not go through the list of all of the papers that were published there, but the main takeaway from that was that there were a lot of popular topics that emerged, such as process mining and automation, especially from natural language, introducing conversational interfaces, dealing with multimodal inputs, a lot of these problems that we already touched on. So the point is to try to basically say that we need a better synergy between the BPM and AI communities to basically leverage the strengths of both. As we can see from the, whether it was the IPA at AAAI workshop or the AI for BPM workshop that happened a few days ago, there's a lot of work at the intersection of both. And hopefully a lot of interesting things will emerge out of that. So I will end here and can take any questions that you may have. Thank you.
Thank you very much, Yara, for your presentation. Does anybody has any questions? Well, not yet. I will start again. The first thing is that I want to ask you is that if you are working in any of the research opportunities that you have mentioned before, and how, at least just some pieces or what you're doing.
Yeah, so I'll comment on a few things, some that I'm directly involved with and some that are part of our bigger team. Some of those authors on this paper are involved with those. So for example, process discovery. We have some work that some of my co-authors on this paper, in addition to their collaborators at IBM and some other research institutions, are working on how to discover processes from, well, not discover processes, but discover which processes should be automated and which processes are kind of what they're calling hotspots, or basically bottlenecks within a process, that if they automate this, that will allow them to address certain KPIs that are falling behind. One project that I am directly involved in is the composition and synthesis of workflows. So you can think of many workflows that kind of already exist, but then you want to, and you have automation solutions already in place for them. Like, for example, making decisions about a loan, you already have maybe a business rules engine that knows how to do that, and it involves a few steps in there that are represented as a mini workflow. And then you have another mini workflow that maybe you can combine those two. How can you automate the composition of that? And we basically look at planning-based AI solutions for that problem. Another one is the chatbots, which I had presented some work earlier in the session today, related to how can we make sure that these automation solutions have a natural language interface for business users to interact with. Also for explainability, there's a lot of explainable AI solutions out there, but they do not necessarily make use of business process characteristics. And if they basically make assumptions that would not allow you to explain the decisions in a business process situation properly. And so we had actually yesterday submitted a paper along those lines. So hopefully in the coming months, if it's accepted, we'll get to present that. But it basically says that how can we make use of the characteristics of a business process to generate more, to generate accurate explanations, but also explanations that can be understood by subject matter experts that may not be very statistically inclined and things like that. So those are some of the few things that we're currently actively working on at IBM.
Nice, thank you very much for your answer. And the last question is related to the cognitive tasks. Do you think that in any time we can have robots working totally by an independent way from humans, or do you think that cognitive tasks will also be depending on the human perspective?
Yeah, I think it will depend on the specific application that we have. I do think at some point we will be able to have, like, coming from my background is really artificial intelligence, and most of my research had been, before entering this BPM world, has been in robotics, machine learning for like more intelligent cognitive robots. So I would say, like, eventually we will get there, and we are on track to get to a place where we have very powerful robots that are being created. But it's very important to know when we can use them independent of humans and when we should not use them. So even if we can create that technology, it's not always the best thing to do. And so I do think it's very important in a lot of places to have the human in the loop. And it's not a point of, if they're powerful enough, these robots, then we should just let them roam in the world. But we should make sure that we use both human assets and robotic assets to complement each other, and then achieve more, even better performance on certain tasks, on just evolving the world, basically.
Okay. So thank you very much for your presentation and your answers. So I think that we can finish this second session. Just remember that tomorrow we will have the RPA demo session that starts at 9:30 in the morning. And finally, I just want to say thank you to everybody, to all the presenters, to all the attendees. We hope to celebrate a next edition for the next year, and hope to be in a presence way. So stay safe, and thank you very much for your attention. I don't know if Alexandre, do you want to say anything?
Yeah, we had one question, but I guess we are out of time now, unfortunately. But otherwise, thanks. I would like to thank every presenter for very interesting presentations. And yeah, it was a very enjoyable session.
Okay, so thank you very much, and see you tomorrow.
Thank you.
Thank you.